Okay, operations on functions. Did some for you. I forgot to press record, so we're a little behind here. But you've done this already. So, take a look at question 2. That's a set of ordered pairs. In reality, probably that's a pretty straightforward question in terms of a diploma exam. I'm going to leave that for you to do. Okay. And then let's summarize here. So given two functions f and g, the domain of their sum, difference, or product are all the values of x that are common to both f and g. The domain of the quotient are all the values of x that are common to both, but excludes values where g of x equals 0. It excludes. Or you can say g of x cannot be 0. I'll give you these words. Because you know that you can't divide by 0. Those are rational functions by property. So, question 3, those are all polynomial functions. I'm not going to go through too much of that on this page. Oh, sorry, I guess for me it's on this page. If you turn over to the next, so these last two here are in a chart. The properties are going to be in the chart. Okay. So we're going to do those because this is a good review for that unit that we did, the rationals unit this year as well. So here we're going to do this one, which is at the top of your second page, and this one. So g of x over f of x. Okay, so you start doing that. If you want to simplify that, the top of the second page. So factor first. Okay, so you factor, divide out, there's a common factor of 2x plus 1. So that's the simplified form. Remember, if it's a linear over a linear, you could use division and get that into a transformation form of 1 over x. We're just going to leave it because we're going to be able to find these properties and graph it without. Okay, so let's fill in this first column, okay, underneath. So simplified form, we've done that already. So x minus 4 over 2x minus 1. The non-permissible values, remember, you look back to your factored form. So plus or minus 1/2. Now I'm just going to list them like that because it asks for non-permissible values. Sometimes if it's in the expression there, we would say, so over here, I would say x cannot equal plus or minus 1/2. You don't just write down plus or minus 1/2 there, right? But in here, we're prompted by that. Equation of vertical asymptotes. So, if these divide out, remember that is because there's a point of discontinuity, not because of an asymptote. This will give you the asymptote. So it's x equals positive 1/2. Okay. Horizontal asymptote. Remember, go back, take a look. They're both the same degree, numerator and denominator. Or you can look here, they're both the same degree. Coefficients, 1 over 2. So as x gets really big, this is going to approach 1/2. Okay, these won't have much of an effect on it. Okay, so that's going to be, it's horizontal, so it's y equals 1/2.
Hey, it's not like the asymptotes, if we're to like take the inverse.
Points of discontinuity. So there's only one point. It's when x is negative 1/2. says points. So it doesn't say the x value at the point of discontinuity. It says what is the point. So we need the y coordinate. So if x is -1/2, put it into your simplified form. If you put it in back up here, you'll get 0/0. Right? It's not going to help you. You put it into your simplified. So -1/2 minus 4 over 2 times -1/2 minus 1. You don't have to show work. You can do it in your calculator or whatever. So that's what? -9/2 over -2. So that's going to be positive 9/4. Okay. X-intercepts, that's when y is 0. So remember, any factor in the numerator, okay, will tell you an x-intercept. So x minus 4 equals 0, so x has to be 4. After you simplify, right? Because that's the point of discontinuity. So x-intercept will be 4. Y-intercept is when x is 0. So those terms go away. -4 over -4 is positive 4. To graph it, well, we have a fair bit of information here. So your vertical asymptote at x equals 1/2. Okay, and horizontal at y equals 1/2. We know there's an x-intercept at 4, y-intercept at 4. Okay, and this is linear, right? It's a linear over linear. If you were to use long division, you could get it in transformation form, which would be a transformation of 1/x. So this is just going to have 2 arms, right? One arm here, one arm here. Take a look at where your points of discontinuity are. So this asymptote was at positive 1/2. Negative 1/2 would be here, 9/4. That's, just a sec. Negative 1/2. So this is going to go like this.
Yeah, the -1/2 is the x stuff.
Yeah, and 9. But that is higher.
9/4? That's all.
No.
That's what 2.
Oh yeah, that's right. Sorry, I was thinking about 4. So this is here. Something like that. Okay?
Yeah.
2.25. Yeah, I was thinking of the original. So -1/2, 9/4. Okay? And then do this one. My hint on this one, just to save a little bit of time. Yes, you already know how to factor the numerator because it's the same function as over here. But let's start with the denominator. Okay, look for potential integral 0 and use synthetic division to factor it up. You can use your calculator to find it, absolutely. see, that looks like a nice one, that looks like a nice one. -2, let's just quickly check it. Okay, so -2 does work. So that means x plus 2, -2, -3, Now, you'll notice I chose potential of 0 at -2. I did it synthetic, and then I noticed I end up getting the same quadratic. So you don't actually have to factor further because my quotient here is the numerator. But if you had chosen the other one, then you wouldn't get the same. So you would want to factor it, and you factor the numerator. Okay? So really, in this case, I can save some time because I happen to choose that one, x equals -2. Not always going to happen that way, right? And saying that, maybe for my non-permissible values, I'm going to have to factor it anyway. So really, that g over f is a transformation of 1 over x. Translation to f. Yes. So here, we'd say x cannot equal -2. And I didn't factor that. So really, yeah, it saved me some time there. But overall, yeah, we already did it over there. So I know from this, those are the same. So x can't be -2 as well as -1/2 and +4. Okay, so filling in my chart here simplifies to 1 over x plus 2. Non-permissible values. So, yeah, we might not show it because we list them. Okay, then vertical, that's the one that's left here. So that'll be x, oh gosh, x equals -2. Horizontal, this numerator degree is less than the denominator degree, so it's 0. Point or points of discontinuity, we have 2. So -1/2 for x, 4 for x. Okay, so you substitute those values in. So -1/2 here, plus 2 is 3 over 2. 1 divided by 3 over 2 is 2 over 3. 4 in there is 1/6. Okay, x-intercept. If the asymptote's at y equals 0, you tell there's not going to be an intercept as well. There's no x in the numerator there. So there are no x-intercepts. Y-intercept is when x is 0. So substitute it in, you get 1/2. And so we can do a little sketch. And so vertical asymptote at x equals -2. Horizontal asymptote. Remember, this is a translation of 1 over x. So this is just going to have 2 arms as well. Okay, our y-intercept is 1/2. X-intercept is 4. Oh, sorry. x-intercept, y-intercept, then, so we know our arms are going to go like this and this. Points of discontinuity, so negative a half, 2/3. So it's going to be about there. 4 and 1/6, say about there. It's a little hard when it's so tiny, right? Okay, so it's something like that. It's pretty small. If you don't label those points on this stuff. Okay, so the next set are rationals already. So we kind of talked about rationals. I'm just going to leave that. We've already done rational expressions back in math. That's 10. Then question 5 is all radicals. So 5, we're just going to do D together. This is a little bit harder. So think about how you would simplify that. We don't want radicals in the denominator.
Actually, you can factor first. So you can factor the third, I guess. Take them the whole time. Even from the top, like, factor of 100.
From the entire thing or from where?
From the entire thing. Because then it's just x minus. Root x minus. A factor of 2, what am I saying? Factor of 2. You know what? No, that's it. 1/2. Whatever.
Okay. Yeah.
Making myself do
Okay. So to rationalize, you want to multiply through by the conjugate of the denominator. If you want to factor out a 2 from here, you can. Okay. And then multiply through by root x plus 3, top and bottom. Or you can just go from here and then simplify. That 2 will come out at the end. So you might not notice right away, but then you can, okay, I got to multiply through by the conjugate. So it's really up to you. You factor that first, because in this case, you are likely going to have to simplify at the end. So, okay, so if you had factored, then you may not have to simplify, but now you'll see here, I can divide this out, 4 out of this, only a 2 out of this. So you could show that as 2x minus 18, that's fine as well. Okay, so for sure, your non-permissibles can have 9, right? Does that make sense up here? If you were to look back, really we haven't sort of factored, we've multiplied through, but we don't count that, we don't look for non-permissibles through by what we're counting or multiplying through. Non-permissibles are, if you take a value and substitute it at the beginning, or at any point along there, will it make it undefined? So at the beginning, let's check 9 in there. 2 times root of 9 minus 6 is 0. So that's the same non-permissible. That or this. Okay, will be so just remember to check for this.
Oh, and since we're going to do your limits.
Oh, right. True. So in this case, if you're asked for the domain, and state the domain. So that's our restriction, but for our domain here, we know that x has to be greater than or equal to 0, where x cannot be 9. It's and I forgot to put it there. Okay, exactly the state the domain of these structures. Okay, so then we get into some exponentials. So we're just going to do B together. Okay, so B is determine the simplified expression and state the domain for m of x. Okay, well, what's m of x? It's m of x here, where h of x equals m divided by m. Well, if we want to get m of x then m of x equals f of x over h of x. Okay, so h of x over 256 x, that's a plus. Can you express 256 with the base of 8? 64 times 8. So you want to go to base 2. I don't know how many times students will tell me this answer is 2 to the negative 5x plus 24. Remember, you subtract everything here. So 3x minus 8x is negative 5x minus 24.
I did this one over. A little bit we got on the problem.
So it or 1 over 2. Now, if it says, oftentimes we might say show as a power with positive exponents, so you have to show it like the second version. Sometimes we do it like that. So either way, in terms of the domain, remember the domain of any exponential is all real numbers. Okay. Think about these. There's horizontal translations in F, G, and H. In this case, we're doing it. F and H. So, in this case, H, which is this function, ever be equal to 0? No. Right? So we don't have to worry about values of x that will make this undefined. This will never be 0. So your domain is all real numbers. Question 7, some trig. And remember how to come up with the equations.
Well,
It doesn't specify you sine or cosine.
I mean, it makes life easier if you take the same one for both, like cosine, cosine. Depends. Actually, no, it's not that much. Oh my god.
Who's asking what the amplitude is?
Josh, seriously,
They both have the same midline.
which is really nice. Well, pick the nice one.
So I'm going to choose cosine for f of x. Okay? For cosine. Because then there's no translations, right? And then you want to look at, okay, from 0 to 2 pi. So that's what a normal, so it has an instruction. So that's just cos of x. For g of x, I mean sine, because it goes through the origin. The amplitude is 1, so it's just going to be sine. And now this has a period of pi. So my b value will be 2 pi over pi, which is 2. So it's going to be 2x.
How nice that is.
It is. So now simplified expression for f over g. And to get your formula sheet out, if you don't remember, what's the identity for sine of 2x? It is 2 sine x cos x. Mathematics.
Have you seen that? Not
Not for a long time.
very well.
Don't talk to math. Oh my God. I didn't think that was real. I thought that was
No, that's real. It's honestly very well made. This was made the 50s. This is animated in the 50s.
Okay, so in terms of domain, remember we need to get our restrictions. There's some space here. We'll do it here. So our denominator is sine of 2x. So you can either solve sine of 2x for when it equals 0 or here. Basically, we do not want sine of x. So whichever way you do it, I'm just going to show my work here.
No, for the equation.
Oh, you could, yeah. Okay, so then sine is 0 here and here, cos is 0 here and here. So basically, it's undefined for any multiple of pi over 2. So our domain is x cannot equal n pi over 2. N is integer and x is an element of the same.
Writing the do we use the Z or the I?
On the diploma, try to use I. They'll take this. It's universally known. It's just in Alberta we use I. So try. You have the time. You're not going to be rushed.
I'll let the noise the markers.
Well, it might. So if you have the time to change it, you guys are smart, right?
I did 4 12x, 1 start 4 9x, and then the minus part of the 2.
Oh, okay, so you did a transformation?
Yeah, I got the same domain.
Yeah.
That'll be fine.
Yeah.
It's all right.
Okay, so logarithmic functions. So again, this is kind of helpful on Wednesday. Transformations of log. So it says here, graph of y equals log of x base 2 is dotted curve. Show the transformed function. So find the equation of the other two graphs. And it gives you a hint. They're all transformations of log.
Translations.
Yeah, and specifically translations.
Yeah, they look.
Dotted is your base graph, they're translations, so take a look. 1, 2, 3 to the left. You can check another point, 1, 2, 3 to the left. So horizontal translation, 3 to the left. You place x with x plus 3.
Is that 6?
This is 6. So here, 1, 2, 3, 4, 5 to the right. Check all the other points, same thing. Okay, so now we can add functions together. So when you add these together, you want to simplify them. So you can look on your formula sheet if you can't remember. But when you're adding logs with the same base, you multiply the arguments together. And it says in simplified form. So expand those out. Okay, in terms of the domain, x has to be greater than -3 there. X has to be greater than 5 there. So where do those overlap? X has to be greater than 5. Heavy eyelid. And then subtracting. Remember, subtracting logs at the same base, you divide the arguments.
Never mind.
Okay, so then here, obviously, this has to be true because they're staying, starting with the same log expressions. Can't have 0 in the denominator, but remember, that doesn't have an equal sign. already incorporated that. That will never be 0 anyway. So this will have the same domain. Okay, so that is a review, kind of a good review of operations on functions, and we touched on a number of different functions. We covered all of these in the last year and a half, right? And we went through the ones that kind of are new to us this year. Listening guys in the back, we don't have too long here. Composition of functions is the next part. Again, very similar to what you did last year. Okay. One thing, and maybe I know Laura, I'm not sure. Some students find it difficult from a graph to find composition of functions. So we're going to go to this one here. And we're going to answer a few of these. So again, I'm going to put some dots here. Okay. So we're going to do these few, then we're going to talk about domain in composition, just to remind you about that. And then the rest you can work on your own. But take a look at the graph. It's a different graph from the last one we used. So if it's bracket notation for composition, then you do the inside first. Work just like order of operations from the inside out. So g of -1 is 5. So this is the same as f of 5. So I figured out the inside. Now f of 5, let's see what it is. So f of 5 is 12. So that's bracket notation. Remember that Bob notation, F open circle G. So now we do the rightmost function first, so G of 0, and then you work back left. So this is going to be F of, I sometimes convert it to bracket notation. So now I find G of 0 is 4. And then f of 4 is 5. Okay? This one is working back. Now you're asked to find x if a composition of f of g equals -3. So it's like undoing an equation, solving for x. So this is saying f of something gives me -3. I need to look on the f graph for when f is equal to -3. There and there. There are two places where f is equal to -3. Okay? So, f is equal to -3 when here when the inside, so f of 0 equals -3. And f of 2 equals -3, right? Well, now g is at 0. Okay, so therefore g of x has to equal 0. Here, that means g of x has to equal 2. Now you look at your g functions. So g or function. So when is g equal to 0? When x is 4. When is g equal to 2? When x is 2. So you're working from the outside and going back to the x. You can always check your answer. So if I think x equals 2, then I'm finding f of g of 2, just like I did these other ones, right? So f of g of 2, g of 2 is 2, f of 2 is -3. Works. Then check it for the other one. So same process, You do the next two. Okay, this last one here. So this is g of f of x equaling 9. So that means g of negative 5, we know, equals 9. We're going the outside part. That means f of x needs to be equal to negative 5. But if I look at my graph, there are no points on f that equal negative 5. So there's no solutions to that. There is no value of x that will give you g of f of x equaling 9. Okay?
Where are the
Look further down at the. Oh, maybe they're not. Are they not up?
Well, what?
They may not be up yet. I'll have them look. Yeah, they would still be in that 20, although the extra parts for the last one may not be right? But composition should be the same. So, in the last few minutes here, you can go through the composition from last year. It's similar to this year. Just get out your calculator. I just want to remind you, I'm trying a blank screen here. So if I give you f of x equals x squared, and g of x, let's say, is x minus 1. Okay? So I'm going to do f of g of x, and then g of f of x. In terms of the actual domain. So we want to think about the domain. So if I do, actually let me just move this. So your calculator actually can really be your friend. A lot of times, but especially with composition. Okay, so when you're asked to do a composition and simplify it, so say we're doing this one, you don't have to copy this down, just follow along. So f of g of x is x minus 1. Oh, you know what? Let's make a radical of that. Okay? So let's do a radical. And so then f, we're going to square that. Okay, so when you simplify this, you get x minus 1, which is a linear function. Oliver, what's up? Right? So, if you think about the domain of this, you would think that alone would be x element of the set of reals, right? But what we put in here, in the original, we can't have all real numbers going in there. And this is a composition. So it has to be able to work both at the beginning and the end. This domain is x greater than or equal to 1. This is all So, if you didn't check, and you just said your domain is all real numbers, you get this part wrong. But your calculator, if you put it in the unsimplified form, so if you put it in like this, it will figure out the domain for you. Well, I mean, it's not going to spit it out in that form, but you will see what it is. So bracket, square root, x minus 1, close the bracket and square it. So don't do any simplifying, just enter it. Noticing you'll only get part of a line, right? You get where x is greater than or equal to 1. So when you're doing this composition, find maybe even write it down. Your inside function and your final, where do they overlap, right? Just like we did for logs, they overlap here. So this is your overall domain. This will check. If you put the simplified, just 2 more minutes, 1 more minute. Okay? So careful on that. G of x. So here this would be root of x squared minus 1. That's going to work out for you anyway. Actually, yeah, because of, so here you would take a look at this domain. This has to be greater than or equal to 0. So x has to be greater than or 1 or less than -1. Guys at the back, just give me 1 more minute. Where does that overlap with the inside x element of the set of reals? Then it should be all of that. So here, let's graph that is square root of x squared minus 1. And you should get 2 arms. Okay? So if you don't simplify it when you put it in, it will show you the domain you're supposed to have. So that's a bit of it. Okay, so I know that you might be studying for the next test. Spend a little bit of time on composition so you don't forget all about it. So that's it for